Another key figure in the semiconductor world, Lip-Bu Tan. Over his amazing career, Lip-Bu has invested in more than 240 companies, earning a reputation as a leading figure in the industry. Recently, he was the CEO of Cadence, where he led the company through a remarkable turnaround. Please join me in welcoming Lip-Bu Tan to the stage to share his insights on expanding global opportunities in semiconductors.
Well, Your Excellency and all the honorable guests, and I'm honored to be here to give a keynote speech. And I will share with you some of my observation in this industry for 40 years, and then some of the recommendation I will make to you. So my title actually is, if I can go back, and opportunity and challenges of building future design and manufacturing semiconductor ecosystem. I think this is very timely in the neutral kingdom like here, and how to build that. Our industry benefit a lot by the 5 drivers. The industrial IoT, autonomous driving, hyperscale, and 5G. But most important is the AI. And AI, ML is driving a lot of growth in our industry. And then if you look at we call it the Magnificent Seven, if you are in that 7 company, your fund perform very well. And it's all driven by that. But more exciting is a 1 trillion semiconductor industry is happening. And a 3 trillion electronic system is coming. And I think we underestimate the potential of that. Secondly, I just want to highlight the adoption of technology is very fast. And it takes about 4.5 years for Facebook to reach 100 million users. And then TikTok, 9 months. And ChatGPT in 2 months. And that's a humongous growth opportunity. Then I think if you look at the whole changing of the landscape is tremendous. And I just want to highlight 85% of the data is unstructured data. And we today only use 2% of the data to use for application. So it's a very complex and huge opportunity in front of us in terms of system level growth and system design complexity, and then more than more, and also some of the challenges in front of us to solve as engineers. And then if you look at the data, it's massive. 3,000 gigabytes per hour per user. And like Netflix, like all the different applications. And then the transmission, storage, and processing is completely changing the whole infrastructure, and it's a time to making some of these big bets to drive some of this opportunity. And I kind of look at 3 big areas to make a better world. One is sustainability, clean energy, and then renewable energy. And then general AI, in my view, is much bigger than internet, the implication. And we are just the beginning of it. So it's a really good time to be in this industry and then transforming this whole industry globally. And I think Kingdom can play a very important role going forward. And of course, the other part is the digital biology. And this is using AI machine learning, using a lot of patient data to drive more accurate biomarker and also drug discovery. And I think this area also going to be a tremendous opportunity, and I will elaborate later on. And then all this technology is really driving performance, efficiency, scalability. Those are the 3 key words to really make the impact. And there's a lot of innovation needed. And that's where I think is a really good time now to invest in semiconductor. And I still remember 20 years ago, when I go into some of the tier one venture firms like Sequoia, Kleiner Perkin, Benchmark, they are all friends of mine. When I talk about semiconductor investment, the partner may be attending, less than 20 minutes, half of them gone, excuse themselves, and I'm only left with two sympathetically listening to me. And I said, well, do you have any software service company? We'd love to change the subject. So now the world is changing. Everybody asking me, Lip-Bu, what is the next big thing that semiconductor you are backing? We want to follow. So it's a day and night changing. So the innovation is tremendous going on. And then I just want to also emphasize the whole semiconductor development, not just the silicon itself, and also very important, you need to have a full stack. So the software, the platform, it plays a very important role. Later on, I'll elaborate more. So this is just show you the chart on the left-hand side, the massive growth into the, I call it the AI semiconductor in the cloud and in a data center. And then on the right-hand side, it's just the beginning of the edge processing capability in growth. And they are very different. In terms of cloud, it's a massive growing right now. And the capacity and power requirement is tremendous. And you see that, Microsoft Satya is a good friend of mine. He go into 3 Mile Islands to reactivate the nuclear. And then if you look at Amazon, I'm very dear to Amazon. The main reason to do a partnership with Intel on the Ohio fab is purely because of energy. And so this is a very exciting time. And then the edge is just a beginning. And that means that you need to have a very efficient, low power, and a computational capability, and also able to really drive the processing application on the spot to drive performance. This just shows you the whole industrial 4.0 and how rapidly it's growing on the edge growth. And let's look back into, I mentioned earlier, the software, the importance of software. I call it software 2.0. Software 1.0 is when you build the hardware, you try to build the software to make it work. Now it's the other way around. It's a world changing now. It's a software-defined hardware. And then so you really need to start from the software to drive the hardware, the processor, the semiconductor to make it effective, and virtualization of that. So that's a very big change from building the ML models and then low-code or no-code to build the software for the general AI area and then designing the hardware. So it's a completely changing, and many people didn't realize that. So this is where the value creation is happening as we speak. And I highlight some of these challenges because when the kingdom wants to move into the semiconductor, it's very important to think about 5-year, 10-year, 15 years from now, so that you make the investment now, you will be able to continue to benefit from it rather than obsolete. So the investment side becomes very important to be very intelligently, smartly investing. So some of the industry challenges is geometry, scaling, data scaling is very important. Power, data center power, this is a huge bottleneck. The industry is trying to figure out how to solve that. And then, the scalability, the throughput. On the other side, beside the challenges, is a solution. CMOS is running out of steam. The Moore's law, double your performance, double your improvement, every 18 months. Now it's slowing down. You need some new material, like gallium nitride, silicon carbide, indium phosphide. So you have to look at some of this application. Like gallium nitride, I invest quite a few companies. Very good for, this different application, RF, and some of this application is very important. And so I think you should really look at that. And the other part is also some new material required. You basically go into the glass, going to the artificial diamond. They are the very good heat insulator. It's very important to look at that while you're starting to put investment into the area. You have to look at what is the future going to look like, what is the disruption going to be. And then clearly the edge, optical is the way to go, but it's not easy to do. And then you have to do that. And the energy efficient architecture. And I think you know that my good friend Jensen, he built a $3.5 trillion company. And basically it's using the GPU architecture. It's very power hungry. And later on I will share with you, we have to find new way to address the new power efficient architecture to drive the performance that you want. And then I mentioned earlier about the whole system design, the advanced packaging become very critical. And then lastly, the software define the hardware. And that's a very important solution you need to drive. So whatever investment you have to think about, how do you scale it? How do you drive the performance at a low power and the efficiency? I think those are critical throughput that you want to have. I just want to share with you when we look at this whole semiconductor value chain, and I make some of the square. Those are the companies that have deep partnership. Either they are investing in my fund, or I work very close with them. I sold them some of my investment, so make them stronger. So some of them, they jokingly, some of the CEOs say, Lip-Bu, you are my outsourced R&D. Whatever you invest, we love to buy. And that is kind of interesting. From memory, SK Hynix, Samsung, Micron, they are all investors with me and work very close with my company. And then I used to be on the board of Intel. And then you move up some of the fabless company from Broadcom, Marvell. Marvell, I sold them 3 companies that I built, including Inphi. I sold them $10 billion for that. So they really built their business. Same thing with Qualcomm. Cristiano, he bought one of my company called Nuvia that I built. It's one of the best AI architecture. And they bought it without my chip tape out. And he said, Lip-Bu, I need a CPU team. So right now, he's benefit from it. The client PC, they have the ARM base. Microsoft and 40 OEM are using that. It's very disruptive. Same thing with AMD. They just bought the Not AI. And I told Lisa, is a good friend of mine, how do you need to build the software stack? And he bought one company, Not AI, and also support me on 2 other investments to really drive the performance to be the CUDA compatibility. So that's something that's worthwhile. So all in all, I think in China, I helped them to build the SMIC. In Taiwan, I helped them to build the power chip. And so I think the entire food chain, I'm very familiar. If anything, I can be helpful for the kingdom to drive some of this value is very critical. I investing about 500 companies, 143 went public, and 96 successful trade sales. This page is very interesting. It's a semiconductor bet that I put investing, ranging from new processor, we call it XPU, not CPU, just XPU. From Annapurna Lab, I sold it to Amazon, become their secret weapon. Graviton, you may have heard of that. It's come from that. It became the top 10 customer of TSMC. And Nuvia, I mentioned earlier, I sold it to Qualcomm. Lately, I also built a company called Sambanova. The main reason I invest that because GPU is very power hungry. So I like the architecture it's called data flow architecture. It's really helping to optimize for the AI application. And that's why 7 years ago, I made that investment. I'm delighted, working closely with Kingdom to deploy that in the Kingdom to drive some of this power efficient application and then driving the faster speed and lower cost and also the most fastest performance and accuracy is very important. And then the other part is focused on interconnect because chip has become very complex. You need to have the interconnect. So I invest in Mellanox and then sold it to NVIDIA for the Infinity Band. Then I invest in Astera Lab, just went public last year, huge IPO, almost 10 billion market cap now. Credo is doing the active Ethernet cable to connecting. And then lately, I've been focused on this whole edge computing area and then how to really drive some of this improvement. And happy to share with you. And then the other part I also focus, after the AI, the next big wave is quantum computing. So I invest in some of the quantum computing company and also the software, just like EDA, but the software for quantum computing. That's you have to think ahead of time how to drive that. On the software 2.0, it's very important closer to the data. So I invest in Databricks, I invest in the number station, and invest in the, this Galileo. The data is very important to be accurate. If the data is not accurate, real-time accurate, otherwise garbage in, garbage out. So it really makes you focus on accuracy of the data and how to label it correctly, and then how to use it. And then the other part, if you look at the MLIR, this is a software stack for all the processor to work. And that, I back almost 3 different companies, actually 4 now, basically completely changing and replacing CUDA. And that's something that, is very important. You don't want to have one CUDA control everything you do, and you want to have alternative, and that's very important for the kingdom. And of course, the other part is how do you drive optimization for cloud usage? And sometimes I love Microsoft, I love Amazon, but they are not the cheapest. So you have to use how to drive performance. So we invest in a company called Extoterra, basically able to drive the cost down 75% by using different software to drive that. So I think, again, we just have to use the technology in the right way. And then the last 18 months, I invest a series of general AI investment, and this is a game-changing. So give you some idea, like Together.ai, less than 2 years old, company revenue is $500 million, and basically try to drive efficiency using the AI cloud. Typeface on content creation, and then using general AI. If you look at LG, new marketing campaign, is all done by general AI typeface. And he used to be the CEO, executive VP, CTO, and chief product officer of Adobe. And some of these are very disruptive. And Rock's data that is helping the sales executive to be more productive using generative AI to even helping the customer how to write the email or social media to reach out to the right people. And this is completely changing what Salesforce.com can do. So using the generative AI, you can disrupt the incumbent business. So that's something is very, very exciting. And that's something for, for the kingdom. If you want to look at the generative AI, you look at some of this application to disrupt the, the incumbent. And that's where you can really become the leader in going forward. The other part I'm very passionate is using AI machine learning for drug discovery. And one I just want to mention on the bottom right called Echo Neurotechnologies. This is using the brain wave, using semiconductor to interpret and help Parkinson's patient to communicate 82% accurate. And he's not stopped here. He's talking about depression, working on Alzheimer and epilepsy. And that, to me, is a fantastic opportunity using AI machine learning with the patient data, addressing the cancer, addressing some of this illness, and then help the people can have a better life. So something that I'm very passionate, and I know Kingdom is doing quite a bit of work on this whole bioanalogy and the virtual hospital. I'm looking forward to visit. And then I think the quality of life is so critical. And in fact, I talked to Satya, I said, Lippo, on the COVID situation, everybody worry about the physical health. Actually, right now, the biggest worry right now we have is the mental illness. And then it really affects the productivity of the enterprise or the world. And so something that we have to pay attention to the using the data to drive efficiency. Just a few slides, just to share about, 15 years I spent in turnaround Cadence Design. For all the design activity, IP and design software is critical to optimize and drive improvement for the productivity. And in fact, beside the EDA, we move into system analysis, system modeling, so that more system design is critical. And just to show you, using generative AI, we tried in significant improvement in terms of productivity. So something, I'm so excited about Naveen on this National Semiconductor Hub, and then how do you use some of the IP and tool to help our fabless company to drive more productivity in the design, and that's critical. The other part I just mentioned about SambaNova, and this is the architecture, is a data flow architecture that 7 years ago I backed because I felt that GPU is too power hungry. And guess what? We provide the fastest, on the Llama 3.1 405, we're able to deliver 140 tokens per second compared to NVIDIA, only 20 tokens per second. And then we basically provide 10 kilowatts compared to NVIDIA, more than 10 times, 15 times the power requirement. So again, this is just something that you have to think ahead and investing the whole full stack, not just the silicon, the whole system, and the whole software stack. And this is just show you the performance difference and the power difference going to be. And the other part is, when I was at Cadence, I was very hard trying to buy ARM. And unfortunately, the Masa is a good friend of mine. He decided to sell it at $40 billion. I cannot afford, I only offer $26 billion. And then with that, some of my customers said, Lip-Bu, we need to accelerate the RISC-V, the open source, and then also drive performance power and compatibility. And that's why, a few years ago, I formed a team. I think later on you'll hear from Puni and the team to drive this whole, we call it the acceleration with the CUDA compatibility. That's what the industry needs. And again, you have to be thinking ahead, making the right bet. Finally, I know, everyone is thinking about, I think Kingdom also thinking about the foundry business. I have this 6 pillar. I think it's very important to really build a foundry. You need the capacity to really drive the leadership. And then you need to have the process technology. That's not easy to do, but you have to get the smart people like PDF and a few others to help you to improve the process. And then the other part is, is a service mentality. Every customer have different design methodology. You have to learn how to use that from IP and the EDA tool. And then finally, most important is the whole ecosystem you need to build. And then the other part, you're building the trust with the customer. Customer will not come to you for your foundry unless they know that you can be trusted. And then if you are competing with the customer, the customer won't come to you. That's why TSMC never in competing with the customer. That is very important. Finally, you need a lot of patience. It's a long-term game, and you cannot just do it for 2-3 years. And you take a long time. I worked with side by side with Maurice Chung, and it's long-term, 10 years, 20 years, 30 years to build that business. So it's a sustainable, a lot of patience is very important. With that, I just want to give a couple of recommendations for the Kingdom. So first of all, I think it's very important to build a resilient design and manufacturing. And I think Kingdom in the very well positioned, be a neutral country to do that. And right now with the China-US tension, and it's going to be difficult. And then I think the Kingdom have a lot of talents, a lot of opportunity to do that. Secondly, it's important to form partnership with some of the industry leader. This is very, very important. You don't have to do everything yourself. You can partner with some of the leader. And I'm glad to see that you are partnered with IBM, partner with Qualcomm, partner with different industry leader to leverage on their capability and scale, and then we can pick up from there. And then thirdly, it's very important to build the design capability, and I'm so happy with Naveen's effort on the NSH, and I think with all your support on doing that, I'm very, very happy to be helpful. And then important to build the long-term semiconductor strategy. As I mentioned earlier, you think about thoughtfully where are the right decisions to make. Strategy is very important to implement. And then finally, it's very important to attract and train the semiconductor talents and globally. And I was involved with 4 universities. I was highly recommend, especially in this AI era. Carnegie Mellon is a very good school. I'm a trustee there. I'm a School of Engineering advisor and board. And they are the best in computer science. And then secondly, the best in robotics. And they even the first university to offer AI degree. And some of these students, you should hire them over here and get them to train here. Secondly is my old school, MIT. And I rejoined the Dean of Advisor on their School of Engineering. And they are very strong. They're #1 in engineering. And then a friend of mine, the Dean is Ananta. He's wonderful. And I like him a lot. And he said, Lip-Bu, I need you back. Because I was trained as a nuclear engineer. They want to pick big bet into nuclear fusion. So I was happy to work with you on the nuclear fusion side. And then next one is the Berkeley. Berkeley, I serve on 2 advisories, School of Engineering and a new school called Compute Data Science Society. That's where Databricks come from. And this is the whole data management. Their team is really good. And the Rice Lab and many labs, I came outside because those are the great place to hire and recruit the talent. And finally, Stanford. Stanford very strong in AI. And Chris Ray is a founder of Sambanova and also founder of Snorkel Together.ai. I back him with my investment. I'm an anchor investor in whatever he do. So with that, I want to just thank you so much for the opportunity to speak here. And I'm looking forward to work closely with the Kingdom. Thank you.